Oh, hey everybody. This is Stephen Ramsden. I am a solar astronomer, and today we're going to talk about the sun. The sun is super cool. It's the closest star to the Earth. It's 93 million miles away. It's made out of hydrogen. It's a gigantic nuclear furnace where the gravity pushes all the hydrogen together until it gets so hot it explodes. It's called nuclear fusion. That explosion creates helium atoms, and it also, more importantly, creates light. All the light you see around you, outside, anywhere you go, is created in the core of the sun, 93 million miles away, travels all the way through space, through our atmosphere, bounces off all these leaves and telescopes and faces and plants and animals and birds. And that's why you see them, because our eyes have evolved to become sensitive to these wavelengths of light created by our nearest star. And that's why you see things. That's always fascinated me. You know, our eyes absorb these wavelengths, translate them into images in our brain, and that's how we communicate with each other visually. The sun is really cool. I grew up here in Atlanta, and I went to Atlanta area public schools, and I learned about science because some of the teachers saw more in me than I thought I had. They showed me some science, and I thought it was really cool. It turned out I was pretty good at stuff like that, and I started learning more and more about science. And then I went into the military and studied nuclear physics in the Navy. Then I became an air traffic controller after that and used my three-dimensional math skills to have a really successful career and a good life. Retired at 48 years old. I started the STEM program after that, the Charlie Bates Solar Astronomy Project. We taught kids all around the world about sun, and we still do. The sun is cool, and it's a great subject, and hardly anybody knows anything about it. So if you want to learn something really neat that you can use the rest of your life, get into science and study the sun with me. We're going to take a look today at what the sun is, what some of the features are, and I'm going to show you a few places that you can go to study the sun without even leaving your living room. You can do it from inside your house. Okay? So let's go take a look at stuff, and when we come back, we'll talk a little bit about how you can look at it other ways at your house.
So these are the telescopes that we use to observe the sun in different wavelengths of light. These are the computers that we use to take the images. This is the sun in hydrogen alpha, which is a near infrared wavelength that's 656 nanometers. You can see when I add the color into the image how beautiful it is. The large white area on the bottom right is a solar flare going off, which is about 2 million degrees Celsius. The dark areas are prominences and filaments being held aloft by magnetic field lines. This is a white light image of the sun showing a large sunspot group. Again, the darker the color, the cooler the temperatures. So the dark spots are maybe 5,000 degrees, while the whiter areas are about 10,000 degrees. And this is the natural color being added in. These are called sunspots in visible light, which is all wavelengths. This is a beautiful image in near ultraviolet called calcium K wavelength. The same solar flare is visible and you can see the sunspots. When you add in the natural color to this image, it shows a purplish bluish haze, and this is characteristic of ultraviolet light. The sun is visible in all of these wavelengths through telescopes from inside the Earth's atmosphere. This is a close-up of the solar flare going off. Notice the fuzzy little flames on the edge of the sun. Those are called solar prominences. You can see the core of the sunspots here as well. A great way for you to watch the sun anytime, day or night, from your living room on the internet is the NASA Solar Dynamics Observatory page at sdo.gsfc.nasa.gov. You can also just search NASA Solar Dynamics Observatory to get there. This is a real-time view of the sun in 14 different wavelengths and magnetic strengths. You can start at the front of the page and just click all the different wavelengths if you'd like. These are all extreme ultraviolet wavelengths and magnetic fields. If you want a closer look, you can click more images and it takes you to all the various instruments on the satellite, which by the way is orbiting the Earth looking at the sun. So if you want to see this image, you just click it And this is extreme ultraviolet, showing right now what's going on in the sun. If you'd like to see a video of what's been happening for the last 48 hours, you can click any of the images and choose the 48-hour video feature. It comes up and starts playing. This is an absolutely fantastic resource of real live data from the sun 24 hours a day. A great website for teaching and for learning about the sun. When the sunlight gets to the earth, it provides life to every living creature on the planet, including this tree frog, which is on a stem in the forest, reflecting the green wavelengths of light from the sun. And these ebony jewel-winged damselflies, which you can see breeding here on a leaf in the woods. You can see these anywhere you go walking around on trails and things. Notice when they change their position relative to the sun, the different colors show up on their bodies. This is called angle of incidence of sunlight, and the molecular boundaries in the insect's body actually change the wavelengths that they reflect into your eye. It's really a fascinating thing, this whole study of light. Here's a beautiful eastern bluebird female feeding a little unfortunate spider to her babies. All the colors in this photograph, video, are also directly from the sun. These blues and reds and yellows and greens are all simply reflections of different wavelengths of light from the sun.
Okay, I hope you enjoyed that. And how can you look at the sun yourself? Well, did your parents or you get any solar viewing glasses for the eclipse back in 2017? Are they still laying around in your drawer somewhere? You can take those out and put them on your face and look at the sun anytime you want to. You can see sunspots, and you'll see a big white or yellowish round ball of hydrogen in the sky. And it's really cool, man. So you can use your solar eclipse glasses anytime you want to look at the sun. Another way is by getting a solar telescope. This is a Coronado PST solar telescope made by Meade Instruments. You can get this for Christmas maybe and put it outside and look at the sun anytime you want. This shows you the sun in infrared wavelengths, like some of the cool pictures we just looked at. You can see solar flares, sunspots, prominences, all kind of cool stuff with this consumer available little telescope. It is really cool. Other ways, you can go to local observatories. You can also just get on the internet and study the sun on your own. The NASA site Solar Dynamics Observatory that I showed you a minute ago is available for anybody to go study. You can see what's happening on the sun right now, anytime you want to. So I hope you take this information and go think more about sunlight and how it affects your life and how cool it is and how everything you see in nature is just a reflection of the sun. So go out and look at some birds and animals and plants, take some photos with your phone or whatever, and let's talk about them. Come join my Facebook group at Sunlit Earth and share what you've learned about the sun with us. Tell your friends too, because it's great to share knowledge with other people. Again, this is Stephen Ramsden, the director of the Charlie Bates Solar Astronomy Project. Go learn some science.